Dan and I started doing research with the yield igniter in 2009 and all the way through about 2016 or so, and we're still collaborating on stuff. Hopefully start up some more again here soon.
All right. So I'll let Nina take it away.
Okay. So yeah, the Humic research is really interesting. There's a lot of things with it, but when you come to know the Humics, as far as the so-called structure of it, and when I say so-called because there is no one structure of it, Isaac, we lost, oh, there it is. It's a chain of carbons with all kinds of functional groups on it. The key is what's on those functional groups. The mechanisms, we're working on it. We have an idea of what it might be, but basically it all comes down to what's on those carbon groups. I could have used some Humic product on my face after going to the dermatologist. Maybe it would have taken some sting out and burn out of that. But so all you guys that are in the fields, don't discount your putting sunscreen on. That I'm paying the price for that now. So I'm going to go through a bunch of the research that we did with the yield igniter Humic product, starting in 2009. Like I said, we went to about 2016-17, and give a little background on all of that. So Dr. Dan Oak and I have been working together the whole time on this. He is in Phoenix right now, giving a similar talk down there to the Fluid Fertilizer Foundation, and I just got a text message from one of the organizers. They just gave him a big award down there. Terry Grimard, he's a technician in our group and does a lot of the chemical analyses. The pictures that you see up here, this is the stuff that we have seen repeatedly over the years. There's definitely growth stimulation going on, where it shows in the corn ears, the roots, and the cob lengths. So as I mentioned, yield igniter is one of the Humic products we've done some research with. We've worked with some others, but I'm going to talk today just focusing on the results from yield igniter. So in our previous background on this, before we started doing our own Humic research, a lot of research has been done on Humic products in other countries. It's lagging here in the United States, but a lot of the research has shown fairly consistent yield gains in warm and arid environments. But there's a lot of variability and in response across different soils and landscapes, and that really needs to be addressed. And so we need to look very importantly on the variability in crop response. There's variability to everything, and being able to identify what the variability is and be able to predict what is going to happen is really important for farmers. So until we get there, to be able to make recommendations, it's going to be an obstacle until we get a handle on it. So some of the potential sources of variability, first of all, there's issues with time, and we see that in our weather patterns. And being in Iowa, we have huge variability from one year to the next, and we've certainly seen this in the last 3 years. And there's obvious variability in space. On this aerial photo here, I took that of our fields when I was first started with the USDA doing a nitrogen management project, and that's just prior to planting out there. And that was with the spring of '97. So one of the things that gets me about that is some inputs people completely expect to have variability across the landscape. Like when you consider one of the biggest inputs, nitrogen fertilizer, you do not expect to get the same bang for the buck on the lowland soils where it's got high organic matter as you would on the lighter soils on those hilltops. And farmers accept that because it's true. what we need to try to get them to, everyone to understand that just about every input's going to do that. So humic products are not going to have the same effect in every place in the field. And there's also a potential for differences in response by crop type and variability. So that was one of the goals of what we were going to look at with the humic research. The first thing is that can it have any benefit here in the Midwest, because we have fairly high organic matter soils, a lot of fertility, and there was some question of whether or not it would have much of an effect when or in an already productive system. And then to try to identify what are the aspects of crop growth that are affected for both corn and soybean. And then how do these vary across the landscapes and weather patterns? So when we sat down with Chad and the other people from AgLogic, we first decided to get into doing a field extensive approach, because for them it was really beneficial, because if they're going to be able to sell product, you got to be able to show farmers at least what it would do in their area. We wanted to look at that in the same, for different reasons, but on the same approach, because a lot of the classic replicated plot research, it gets done in just a real small area, and that doesn't tell you the wider effects of it. But we needed to couple that with the traditional replicated plots. And on some of the fields, we were able to separate this by the soil type, as what we know for a lot of inputs drives the variability. And we measured then, to be able to identify what's it having an effect on, we measured the different yield components for these crops. And obviously you guys have been using the GPS, GIS stuff for a number of years now, particularly with the yield monitors, and that has been a fantastic tool for us. It saved me hundreds of hours being able to work with that. So at the AgLogic site at the factory there near Conrad, Chad put together some land to the west of their building site, and we started doing replicated plots. And that's one of the years where we had a lot of replicated plots. So obviously randomized and split plot design, so we could do things with and without the humic product with the same management out there. Some of the things we measured for on the growth aspects were the leaf area and cob length, and looking at nutrients also in the tissue at various times throughout the growing season and end of season, and the grain quality. Hormones and antioxidants, we did a little bit that with the yield igniter. Most of that was done with another company's product though. Then the grain and stover yield, we looked at all of those qualities right there. And of course the end of season nutrients. On soybeans, we looked at stand density, plant height, a multitude of things for the grain. One of the big things that I'll talk about a little bit later is the pod count, and then on end of season nutrients again. On corn grain yield, I've got hundreds of graphs. I'm not going to throw them all out here for you. I'm just pulled some examples. So from that field extensive approach, basically we did it for over 3 years, and we had 95 different site years across Iowa, and some stretching into South Dakota and Nebraska. And this is graph is from that year in 2011 when we did that. 2011, if you remember, we started out pretty good with moisture, but then it kind of turned off drier later in the season. In Nebraska and South Dakota, kind of like in the Bassett area, which is not far from the border with South Dakota by the Rosebud Indian Reservation, it got really dry. And when you talk, I have a hard time calling what those poor people out there have as soil. I would not call it soil. It's beach sand with a bunch of sand burrs. You know, and you got to give those guys credit for being able to farm in that, because that's tough stuff. And interestingly, but not really surprisingly, I've got arrows marking for where those fields are. So all of those are from Iowa, Nebraska, South Dakota tossed in together in one graph. But I picked out the ones from that Sandhills area, and you can see the biggest yield gains came out of those areas. And I'm not kidding. You walked in, you know, when I walk into the control areas, it didn't even look like field corn. It looked like popcorn. It was that bad. And it was just a night and day difference. I mean, still, you know, compared to Iowa corn, it wasn't spectacular, but at least they had something to harvest out of when they put the yield igniter on there. And in some instances, and I'll explain this a little bit more, that you can see on the red bars there was actually some yield declines, but we have an explanation for that, at least an idea of it. Overall for that year, when you lump it all together, on average there was about a 15 bushel yield gain across all those sites. On some of the intense replicated strip plots, this is from one of the fields over by Radcliffe, on the Holacek field, and we had yield gains vary out there by application timing, which was a little bit interesting, but the gains were all from about 6-7 bushel per acre all the way up towards 20. On that extensive approach, again, this is where it was a lot of hours of work, but hand shelling the corn and stuff and measuring the weights on that, but then putting it into categories, and this kind of shows what was going on there. So the PR less than 0.001, that's the statistical probability. That's one of my fun jobs, is doing the stats. And for field research, for it to be considered statistically significant, depending on who the scientist is, it's either 0.1 or 0.05, meaning either 5 or 10 times out of 100 you would expect to get that result by random chance. A lot of scientists use 0.05 or the 5% level. And when I ran the stats on this at 0.001, that means only one time out of 1,000 would you expect to get that result by random chance. This really shows for us that this is for real. This is a solid expectation from using the Humic product on the corn grain. And on that, we got about a 6.5% yield gain, which, you know, some people will go out there and say, well, it's not 10 or 20 or 30, so I'm not too interested in 6.5. But 6.5 bushel per acre, or percent on 200 normal bushels per acre, that's significant. That makes money for farmers. And another thing that I pointed out here on this is that it shows the distribution shift, because when you look at the green bars with the controls, that's that classic normal distribution, that bell-shaped curve. But with the Humic product, it's shifted to the right onto the higher end. So we're not so much making bigger ears so much, but we're getting more out of the smaller ears. You're having less incidence out of those smaller ears, and they're getting bigger. On leaf area, so leaf area can be a pretty intensive measure, and it was for us out in the field. But it's a really good one, particularly with corn, because it's a determinant plant. And it kind of gives you an idea of the growing conditions out there for that plant, because if everything's going good for the plant, it's going to have more leaf area, going to have bigger, longer leaves. And of course, the leaves, that, you know, with the photosynthesis, that's what drives the plant. And that's why it's so important. On that Radcliffe field we went out there, we had in 2010, anywhere from about 6 to 3.5% larger leaves out there, and statistically for the pre-emerge application, that was significant at the 95% level and significant at the 90% level for the other two. And this this was what Mike Rasky would call the agronomist for the company, my Stegosaurus graph. It reminded him of the dinosaur with the spiny fin on its top of its back. So I broke this data down by each leaf at each stage, and you'll see what's kind of interesting to us is that on the yellows, that's the control, the blues pre-emerge, and then green's V3 and purple's the V6, all the way up to about the V8 stage, or prior to that, V7. There's not much difference between them, but then all of a sudden you see starting at V8 that the earlier applications for the Humic product is starting to have an effect. The leaf areas are jumping up over the control. And it stays that way, but the later application on the V6 catches up a little bit later too. So there's a little bit of a lag phase of when there was that, depending on the application timing of it. But with each leaf after that lag phase, caught up and the plant was growing better, we got bigger leaves pretty much all the rest of the way. And on cob length, yeah, I know this is a snapshot picture, but more times than not, I've seen this over the years. Yep.
Question, man. There's a little bit of a lag on that humic acid. So if we put that on with the planter, and then you're saying maybe by V6, phase V7, which we're already past the V4, V5 stage, when we want that plant to be very healthy. Does this stuff, I don't know much about this stuff, so what if we put it on in like if we put it on strip till, like maybe in the fall, the previous fall, is that humic acid already on, it's used up, or is it there, to have it ready to use? That might be good.
That's a great question. We haven't looked at it, and I would really like to. I would be concerned that if you put it on in the fall, if it might leach through. Personally, I wouldn't. I would love to do it on a small plot. I would not do that on a whole field. I have some concerns that it would be gone by the next spring. It should. Because when I talked about when the humic acid, humic and fulvic acids are these long chains of carbon molecules connected together and have all these different functional groups. It also means that you've got positive and negative charges hanging off of those on that chain. So when with a decent CEC soil, it should catch on to some of it, but until we've researched it, we don't know. That's been a concern of Chad's, and we actually took some cores from those fields in Nebraska when we went out there to sample and to try to do some leaching studies on it, but we just couldn't get enough of them to really do a good study on that. That's something I would really like for somebody to follow up on in the future, but if I was farming right now, I would not do that. I would wait to put it on in the spring. Yep. So on cob length, and this is the yield component stuff, one of the many things we measured. So very similar to that other one that I put for grain weight. So what this is telling me, the only difference is that instead of 6.5%, it's 3% longer cobs. But what that's telling me is that 3% was grain filled. That wasn't empty, tip back. That was more grain that was out there. And the cob length is determined somewhere, depending on who you're talking to for plant physiologist, from about V5 to about V12. And so another reason I would personally want it out there a bit sooner, not the fall sooner, but like pre-emerge versus V6, so you can capture more of that increase, during the cob length determination period. Again, statistically, 0.005, that means only 5 times out of 1,000 would you get those results by random chance, so very significant. Yeah, oh yeah. So I did some calculations on this. So, so for every 0.4 centimeters, it equals about 6 bushels. So when that's seed filled, so that another piece of evidence for the farmers that this stuff is for real. On the stover yield, particularly for anyone who's grazing cattle on the stover, very interesting to me is that the percent increase that we had on the grain is almost exactly the same that we had on the stover. So it's not just affecting the grain, it's affecting the whole plant. On soybean grain yield, that we did not do as much work with the soybeans as we did on the corn, but we've got very consistent, again, about that 6.5% increase on grain yield across the farms that we tested this on in 2011. Pod counts, I don't have a graph for that. Most of the pod count stuff that I did was with different humic product, but I just ran out of time. I had a bunch of other stuff pressing on me last week. I've got the graphs, I just didn't have time to put them together, but basically what was going on is that we have more pods, seed-filled pods with the soybeans, with the humic product as compared to the controls. Yeah.
Are they still recommending a V6 application, or what was the stage that these beans were sprayed at?
A lot of ours for our research was V4. Terry, do you guys have, are you still recommending for soybean around V4, V6, or?
Yeah,
Okay.
well, we brought it up some.
Yeah.
To R1. But
Yeah, one of the, I didn't bring papers with me, but Dan and I worked with Andy Lenson. He's now retired from Iowa State. He did a soybean study with the yield igniter too, at various timings of application. To me, it's just as soon as you got enough leaf area out there, if you're going to do a foliar spray, to absorb stuff pretty good is a good time to do it. So that's about V4, V6. Soybeans are indeterminate, so to me it's a whole different plant than the corn. When you got vegetative and reproductive that can happen at the same time, with an indeterminate plant with corn or with soybean, you might be able to actually get a little bit more boost with it than a determinate plant. We did a little work too with sugar beets. Of course, we didn't do that in Iowa. That was a little bit of a drive going up to Wahpeton, Minnesota, or North Dakota, and on the Minnesota side of the Red River, Breckenridge. And actually, that picture's from Breckenridge. There's a lot of research that's been done in other countries on the sugar-producing crops, like sugarcane and sugar beet. In the theory of how it might be working, you would expect a sugar or carbohydrate crop would be really responsive to it. And sure enough, the literature shows huge improvements for sugar beets, sugar cane, and potatoes. Huge benefit on potatoes. In fact, so much so there's areas in Idaho and Oregon where almost every farmer just automatically has humic products in their management program. It's that much of a gain. There's Murphy's laws that exist in research too. In fact, very much in research. So we went up there and for 2 years and did plots with the Mindac sugar beet cooperative, and it was the wettest 2 years they ever had on record, which made trying to do field research even more fun. I'll get into it a little bit more later, but we typically see our best benefits in dry conditions. And so when it was sloppy wet, that was not what we were hoping for. But even in the sloppy wet conditions, there was a little bit of a yield gain to that on the sugar beets. On some of the other crop and soil measures that we did not get any statistical differences with all of these different measures I have up here. So basically, you know, so far with what we've measured, we're not getting, you know, like higher protein, higher oil corn, the corn, or they're not affecting any of those different traits with the soybean. We're just simply getting more grain out of both of them in biomass too.
Ask you, when you did the sugar beet studies, did they come back with sugar
Yes,
and protein?
yes, we did all of those analyses too. Unfortunately, we didn't have an effect on that, and that was in sloppy wet years. Plus, I'll add on those fields, I'll tie that in more later in the talk, but those fields, if you've ever been to the Red River Valley, holy cow, it's as flat as this floor. And the drainage is terrible. And you got sloppy wet conditions. And
The first Acosper spray.
what's that?
I put it on the first Acosper spray. Look for Acosper. Put the product in.
That was because of the location of it. It was so far away from here. We let the guy in charge of research for MNDAC take care of that, and he applied it. I think at the, if I remember right, about the 5 or 6 leaf stage.
That's where I saw my increase when we did it. I didn't know when to put it on, so I put it on the first Acosper spray. Don't know if that's right or wrong. But our purity levels went up and our sugar levels went up. And the value 2 years ago when we did that study was $101 an acre.
That's really interesting to hear because we didn't get to that point in those 2 wet years. But that falls right into what we think is going on with what could be the mechanism of why humic products do what they do. I'll talk about it now because I don't have it in this talk, because we're just getting to the point of being able to put this together for a paper. But we are seeing that it looks like the biostimulant effect of the humic product in a plant it first affects the carbohydrate manufacturing in the plant. To not get too deep into the theory of it, there's a guy, a scientist from Spain, has got a hypothesis that it's speeding up the metabolism by speeding up the ATPase in the cells. So the energy exchange is going faster in the cells, so it's making it grow faster. And in that process, carbohydrates are generated. And so for a carbohydrate crop or sugar crop like that you should expect it. And what we've seen in the potatoes, that's exactly what's happening. So in the research out of Idaho, where they do a lot of the humics out there, the potato quality is huge for income. If you get a small, shriveled, wrinkled potato, it's telling you that the plant, first of all, was going through stress. And that's why you get all those wrinkles in valleys in those potatoes. And they didn't fill out really good. Farmers get whacked pretty hard on the quality for that when they go to market them. So they want those big, smooth ones. And that's exactly what they're getting with the humic product. But what it's doing is because it's getting more carbohydrates in it. And whether that, what the plant does with the carbos after that depends on the conditions. For potatoes, the potato wants to put carbos in.
And we did this on 30 acres, 30-acre blocks.
Okay, good.
So that's huge.
Were you able to look at some variability or from one part of the field to another?
Just when we did the lifting, we lifted the untreated in one block and then the treated in a different block.
Okay.
Those would all go in on separate trucks.
It's all flat fields?
Yeah.
Okay.
I thought it was a good study.
Yeah. Yeah. Was that with MNDAC or was it with one of the other cooperatives? Okay.
Through southern Minnesota, sure.
Okay.
But it was just one grower that I worked with that we did it on a 30-acre block.
That's really,
It was a small block,
yeah.
maybe 12 rows or something. this was actually 30 acres from end to end.
Well, that's encouragement to readdress the sugar beets again. Hopefully not in a sloppy, wet year. Okay, so we'll move on. Moving to plant health, and we're kind of hitting that on there. So good timing on your question, because that reminded me to say something about the plant health that I don't have in here, because when we were working with Mike Metzger up there at the Mindak Sugar Beet Cooperative, yeah, we were really wet, and maybe it, kind of trashed things for having the effect that we thought that we should see with sugar beets. But one thing that Mike went out there and measured also was the fungal pathogen, the disease pressure out there, and he noticed, we don't have a plant pathologist in our group, and even if we did, we didn't have the money to send one up there to measure it. But Mike told us that he saw far less fungal disease on the Humic sprayed sugar beets than he did on those that were in the control.
See, that's what we're trying, when you get the Cercospora in the beet, it sucks the sugar right out of it, and you're selling the sugar content.
Yes.
And I don't know, it was 2 years before that, when it was so wet, the beets turned brown, the sugar was terrible.
Wow.
So that's why we're trying to increase the sugar, but keep the Cercospora out of the plant. I wonder if that's what you were seeing too,
Yeah.
controlling more of the fungal side of it.
Well, one of the things that we've seen with that, and I'm going to show another, well, this picture here was sudden death syndrome in soybean, and then the next picture, I would love for a study to look at the fungal disease pressures, because Chad saw this with one of his sprains on the soybeans here, and one day I went out to the field with Chad. We were going for another purpose to take some soil samples, and then the sun was low, and I turned back and looked towards the farmstead, and it was, here you see that difference in the color in the stover. And then, because I'm allergic to it so bad, the fusarium, I'm always looking for that. And then, so that's what it was when I looked at it. It was the control, which is on to what would be the right of that red flag. It was that's normal corn stover in Iowa in the fall after harvest. The fusarium just grows like crazy on it. But on the strip where we put the Humic product, there's not near as much on there. And then we saw it, so we had that evidence with the sugar beets with less fungal disease pressure. There's a potential explanation for that, because Dan, our biogeochemist, what we're thinking of what's happening, particularly if we get into drought conditions, plants tend to, the $10 term for it is lignify, making more woodier tissue. So you're taking the carbons for the carbohydrates and shunting it more into lignin. It's a plant response to stress. And so there's some other things that happened with another Humic product that we had, a derecho, in 2012. Before derecho was even termed. July 27th, 2012. We had about a 75-mile-an-hour wind that hit here, and it started clear over in western Iowa and got here. And then we had a field just southwest of town here with Bob Finch, and so I set up the plots where I always have border rows before, you don't put any treatments on the edge. So I had 16 rows of border, and then we started our experiment. I go out there the next day, and rows 2 through 15, or 2 through 16 are just flattened. Row 1 didn't get flattened because it was only that tall, being by the grass. And then the first row that stood like a rainforest was our first Humic treated row. And that's what started the thoughts about looking at the lignification. And sure enough, we have evidence that in drought conditions, the plants are more lignified. They have more of that woody tissue. which allows them to stand better too. And to me, this is another piece of evidence. There's more woody tissue with that stover there that helps prevent fungal infection. And some, all these other yield component measures, in reality, they're indicators of plant health, because you're not going to get bigger leaf area, yield, cob length, pod counts, or any of these other things if you don't have a healthy plant. Because if you have diseased, weak plants, all of those are going to suffer. So to not totally deviate, but to kind of go into the soil health part. Now I'm going to tie this into the Humic products here in a little bit. But with the soil health, this is some excerpts I did out of a presentation for NRCS a number of years back. So the soil organic matter, between that and your clays, that comprises almost all of your fertility, your nutrient supplying capacity of a soil. And you can, you even look in the Ecclesiastes for this verse, 5:9, that the increase of the land is taken by all. The king himself profits from the fields. You look at Iowa, you look at anywhere where it's got good, rich, productive fields, and you will see things for everybody is lifted up by it. You go to an area like the Sands Hills in Nebraska, and everyone suffers when the soil is not productive. And if you can do things to improve your soil health and make it more productive, everyone gets lifted up with it. So I know this may be a little bit over the top, but there's truth in it. So if a farmer is going to invest in their organic matter land bank, it's going to yield dividends in the long term. You see that over and over, and we're talking a little bit earlier. FSA is finally starting to take more of account into the value of that increased soil organic matter, because it really does make a difference in the productivity of your fields. So the things like the CEC, the soil moisture holding capacity is increased with greater soil organic matter. And something that I forgot to mention there, I can't remember her name, but the structure. The structure is vitally important. I mean, my goodness, I'm a farm boy. I grew up right by Conrad, where yield igniters made there by Chad and all of the guys. I grew up between Grundy Center and Gladbrook, and it just drives me nuts when I see people do things to destroy the structure in their fields. If you don't have good structure, you're not going to have a very productive soil. And more organic matter that you have in there gives more capacity to build more structure, more aeration. You just flat out can work your fields better. And that is a long-term bank account. So getting to tie this into the yield igniter, this is a picture that I took when we were doing root measures with the controls versus the yield igniter Humic product. And I could go out there and do this all day. You're going to get the same picture time and time again. We always had a better root system with the Humic applications. And as I mentioned, when it comes to the management of the soil, having that increased carbon makes a big difference. You've got more water holding capacity, more nutrients, and just the workability of it. And when it comes to soil carbon, I don't know if you can see that's put a little bit too small a font there, but there's a number of publications out there that are pointing to the fact that most of your soil organic matter that's stable and hanging around in the soil, that's coming from roots, not shoots. Because of just the structure of that carbon of the root is much more resilient and hangs around more. It's not as easily decomposed. And actually the Cindy Camberdella and Jeff Gale, I worked with them. They were from our lab and did a classic study on that. And it just keeps building from there. So on the soil fertility, I mentioned it improves the CEC, nutrient holding capacity. Soil water, the those guys out there in the Sandhills, Nebraska, I was so impressed with them in the fact that they have put a huge premium on doing everything they absolutely can to improve their soil organic matter. Those guys were flying cover crop seed out there in August to make sure that they had something to grow as soon as harvest was done. Because if they could increase their soil organic matter even just 0.5%, it made a big difference to them, and it showed up in the yields too. In the soil physical properties, that having a proper aeration and improving the workability of the soil is, farmers that do tillage, it makes a big difference. So on those measures of the roots, to run you through this kind of quickly, so we measured roots in a number of different years. In 2013, that was a really sloppy wet year to begin with, horribly sloppy wet, and then the faucet just turned off on the 4th of July and turned out really dry. We had big percentages in root increases from the measures we took, 18 and 49%, but the variability was so bad that we didn't have a significant effect on those years. But 2014 and 15, we didn't get as big of an increase, but statistically, it came out very significant. Basically what it was that we didn't have huge variability from one rep to the next, and made the statistics a lot easier to show that effect. This is one of the fields that's over by Conrad that Chad had applied the yield igniter on. In the area between those arrows there is when it was applied. And then we did soil penetrometer tests out there, and this farmer did tillage, so as you would expect, when you do all of that mixing and stuff, that you probably obliterated any chance to see any effect. But literally right to the very first measure below the plow layer, and for this chisel plow, you can see in the control is the red bars, and the Humic treated, the yield igniter is the blue bars, that we had a lot higher penetration resistance in the controls than the Humic treated. To us, that's telling us that the extra roots that we got with the application of the yield igniter was making a big effect on the soil structure. And kind of changing gears a little bit, but I think this is really good for you guys to see particular, because I'm an old farm boy. My dad loved tinkering with things. All the farmers I know, they like to tinker with things. And some people think, well, if a little bit's good, a lot's going to be even better. But don't do that with a Humic product. It's just like a medication. You take a little bit of a medication, it helps you. You take too much, it's going to kill you. And so we talked with Chad, and we wanted to kind of get at this to make this point. So we did what was then the 48 ounces, where the old formulation was their recommended rate. And then we did 72 ounce and 96 ounce. And we got pretty much what I expected. We had the yield gain at the recommended rate. We had lost that pretty much, going 50% greater and doubling it, we got a yield loss. So really make a point to the farmers, don't deviate from that recommended rate. It's going to get you in trouble. So to get at some of our research questions, can a humic substance improve crop production across the U.S. Midwest in rain-fed conditions? And numerically, if we just looked, was it any better than the controls? Yes. 70 to 80% of the time we got yield gains. Statistically, field research, I'll put it this way, the old Betty Davis line. Betty Davis said, getting old isn't for sissies. I'd say, well, I agree with that now too, thanks to the skin cancers. Field research isn't for sissies either. There's so many things that can mess it up for you, particularly when you try to do statistics, but we still came out with statistically significant effects at the 0.05 and 0.1 levels numerous times. And the next question, so what parts of the plant is it affect? Well, we've got significantly increased yields in both corn and soybean. On the corn, we got bigger leaves, and that's a very consistent response. Almost every year, every situation, we got bigger leaves. When we didn't get a yield gain, we still got always bigger leaves.
On the PR 0.1, 0.05, can you explain statistically the difference of those and why? What's important, why you have those two numbers?
That I put up there because being a field researcher and not a lab researcher, the lab, this is one of the things I take issue to some other scientists. Lab research, the standard is 0.05. But those lab researchers lots of times review our papers for field research. And I have constant arguments with them about this in a kind way. When you take it from a controlled environment from a lab, and that's your benchmark for lab research, but then you take your research out to the field and you're in a situation where you're not in control of the rain, the temperature, insects, all sorts of things. That's
You introduced the 1,000 variables that they've taken out.
so 0.05 is not a reasonable benchmark for in the field. In fact, I know some researchers that use 0.2 as their benchmark. The whole key is when we write our papers, you just communicate what that is, and that's what we do. Yep. In soybean, we got more pods. Obviously, if you got more yield, it's more seed-filled pods. So do humic substances affect crop production the same across variability in landscapes and weather patterns? I would say no. We got plenty of evidence. In one of our other papers with another humic product, we specifically targeted the variability in the landscape. And we got significant differences by soil type and landscape. They do not, the humic substances, just like nitrogen fertilizer, is going to give a varied response across the landscape. Now that a lot of guys got the yield monitors and everything else, you can track that yourselves now too, and you can pick up on that. What that's going to do in the future is, so when you find out that, okay, maybe in the wet, sloppy parts, you don't have as good of an effect, and you can turn off, you have an injector for the humic in your sprayer, you can save it and shut it off in the wet spots. Save it for the high spots. But then, you run the risk of, if it turns really dry, you wish you had it out on the dry spot or the wet spots. But that's getting into the $10 term for it is adaptive management. Basically, adaptive management, which you saw a lot in the literature about 10 years ago, is pointing to management practices that you can do to respond to something that happened during the season. And let's face it, a lot of the farm inputs you can't do that with. With the humic product you can, and that's a really important tool to have. In the weather patterns, we've had very strong evidence that you get a much bigger effect in drought conditions up to a certain point. If it gets too droughty and everything dies, it's not going to do any good. But in marginal to somewhat severe drought, it does. You get a big benefit from it. And same with the organic matter. You might get a bigger yield gain in lower organic matter soils than higher because of all the benefits that you're already getting from the organic matter. So for some conclusive points, when we look to the future of what we're going to be facing in agriculture on the whole, populations keep getting bigger. We're going to be pushing up to 8 billion people here soon, and the incidence of drought keeps increasing. You look out to the western United States, and they just recently got a little bit of a break, but 3 years of drought has really sapped them. And in marginal soils too, all the arable land's already in production. So if you're going to increase production, what that means is that it's going to come on fairly lousy soils. And the humic product's one of the few things that you can put out there to try to get more out of those lousy soils. And in some of the future research, we've been trying for 8 years now to try to get partnered up with somebody in the irrigated areas to do a varied irrigation rate with the humic product experiment. I was really intrigued by seeing the results from some research out of the Middle East where they did this, and they found that they could decrease their irrigation by 22% and still optimize yields if they applied a humic product. That was, we really need to do that here. And improvements for water quality, soil health, and the greenhouse gas stuff, it all points to places to be able to improve on those. There's been some interesting research on different things with manure and other stuff where they found that they had less greenhouse gas emissions if they applied a humic product. So for Dan and I, our yield, instead of bushels, it's papers. Yeah.
So, can you go back to your comment about the greenhouse gas emissions in that research and elaborate a little more? Do you have the evidential white paper statistics that we can use to take for sustainability? For, that someone would look at and say, yeah, we can pay on that, do you think?
The mechanisms of that aren't figured out. They just measured that they had less CO2 and less nitrous oxide emissions in various systems with applying a humic product. There are some companies, I don't think Chad's in it yet, but I know some other companies are, where they have their humic product put on oil spills, whether it's on the water or it's on the soil. And the thing about the humics, they're not just affecting plants, they also affect microbes. Because a lot of the same hormones that promote growth in plants are also the same hormones that promote growth in microbes, and a little bit for us too. And when you increase the metabolism of those microbes that can work on the oil and break that down, they were able to clean up those sites quicker. And so for the microbes that can shunt the carbon and nitrogen away from the greenhouse gases, that's what the general thought is how they're accomplishing that.
Microbe effect, not so gases.
What's that?
So you're saying the humic fulvic is affecting the microbe in that relationship?
Yes.
Which is either sequestering or transferring those gases into some other.
Yeah, maybe they're incorporating that into their biomass instead of letting it volatilize. It would be really good to figure that out, to know what the mechanism is, but the end result is they got less greenhouse gases with the applications. Yep. So we've got 3 papers out in press right now. We're going to be working on another one here really soon on the root data. The root data is a slam dunk. I don't expect to have any arguments from reviewers on that at all. It's a night and day difference on the roots. But 2 of those papers, if you guys can jot it down quick, if you want to get the papers, they're open source. Frontiers in Plant Science. Or you just go to Google Scholar and type in Dan Olk or put in my name. There's not too many other Dan Olks in the world, and there's only one Dana Dennis in the world with the way my name is spelled. If you do that, you will find those 2 papers from Frontiers, and you can be able to download them since they're open to everybody. And so with that, does anybody have any more questions?
Did you do any studies with tar spot?
With what?
This product using, see any difference when you had tar spot using this product?
Tar spot was one of the ones that Mike Metzger measured for, and he said there was a fart. It was tar spot, and what was the other one you mentioned? Yes, those 2. were ones that he saw far less incidents with the humics on the sugar beet. And, you know, anecdotally, we've heard from other farmers that, you know, less incidents with, you know, Chad had his picture of the soybean sudden death, or the sudden death syndrome. I've seen it with Phytophthora, and some of the, you know, heard reports from other farmers in other parts of the country too. It would be really intriguing to me to see if what it would do on cotton, since cotton can be really sensitive to fungal diseases. And something else that's going to be coming out here, in my concern, you know, really cool in some respects, but I have one concern about it. If you guys have seen the news articles about Bayer coming out with the short corn for the market. So I've been talking with them because we're going to try to start up a research program with them. Our thing's going to be trying to do a lot of micrometeorological studies with them on that short corn. They said that basically the way it's going to be shorter is that they found the genes that control the gibberellins for internode growth. So for everything from the ground up to the height of the ear is going to be shorter. It's going to be shorter internodes, but leaves are going to be the same. My concern, being an old farm boy, is okay, corn can kind of struggle with fungal disease to begin with. And then now you're going to shorten it and kind of compact that canopy some more. I have some concerns about fungal disease. And maybe this is where, you know, this could help manage that. Because we've seen it time and time again. There's far less fungal disease pressure with a humic product. So if there's no more questions, because I'll hand this off to Terry. Yes?
I think you was talking about sugar beets with tar spot.
Yeah.
Have you seen any instances with tar spot on corn and where the humic acid treatments are making it less of a problem?
I did not look for tar spot specifically on corn yet.
I just didn't know for sure if they were related as far as the organisms go between what is on a sugar beet versus what would be on corn.
I'm not sure. I'll have to look that one up.
Chad did notice it in a couple of our fields where he was doing research, building niter with fungicide and just fungicide. And he noted that the tar spot pressure was less where our product was mixed with fungicide. So it was fungicide and our product with fungicide. He said, he's got some pictures of the leaves, I think, and stuff. We don't have official research. It's just something we noticed this fall when we were walking fields. So he feels like there's something there.
Yep.
So
Yeah.
on that note, would it be relevant to put on your research project or next step if there's major companies saying that an application came forward with fungicide enhances or synergizes their product doing better? How may that be put into research so that it can be proven?
That would be a good study.
So, is that something you could do, your team would do, or we could get official information, not anecdotal information? Hopefully we get it.
That would have to be, to do a good job to begin with it, I would want it under really controlled conditions to begin with, as much as possible. So try to set up a on-purpose disaster in like a growth chamber or the greenhouse. Boy, you'd have to isolate the greenhouse from any other bays in there. But it would be really good, and then take it to the field after that. Goodness, you'd have to take that probably out west where you can go ahead and manage the water. You'd be hit and miss what you're going to get here in rain-fed conditions. But that would be a really neat study. And I suspect that there would be some pretty eye-popping results out of that. I'm trying to remember the strobilurin's, those fungicides. It's kind of interesting because there's some research on those that kind of shows that they may have a little bit of a biostimulant effect too. And so there's probably some similarities in the mechanisms between that and the Humic products and how they're functioning. But the strobilurins, you know, you may get something unintended if you try to monkey with that too much. And you know, we already got issues with the neonicotinoids being used way too much. I'd hate to see, you know, taking fungicides and go crazy with them too. The Humic products they have a much bigger safety factor to them than purified things. Because there's a company that did some research in the past with straight plant hormones. And talking to an agronomist out there in those fields where they did that, he said that they had some really interesting wild results. They could get some really big yield gains, and then they could absolutely kill the crop dead. And the difference between where they got a gain and where they killed it dead was really narrow. So practicality of taking something like that and safely applying them in the field, you know, field situations is non-existent. But it gives interesting results of what might be happening with the Humic product.
Good? All right. Let's thank Dana for coming and talking to us.
Yeah, thanks for your time.